So it's really fast communication for machine-to-machine communication.
In the Windows side, do we have anything like if we run like VirtualBox or like anything on the Windows side? Like, does it do hyper sockets or it goes out and like? But it's on the same one machine. So.
Yeah, on the same physical platform. Actually, I'm not really sure how VMware ESX really would, provide that functionality. I mean, do you really go out and then come back in? Anyone else knows it?
There is a map network drive. You run a VMware on an Infinity OS, and you install another OS on it. Within that VMware OS, you can do a map network drive to access the physical hard disk. Any data on that particular.
But across the machines.
That's for the physical drives. I mean, but if you really, let's say you have two virtual machines. Each of them really have each of them have a different IP address, and then there is an IP to IP communication.
Yeah, goes to the same channel.
Same.
Yeah.
So it's not going out on the network
No,
and then coming back in.
So.
Application virtualization is, again, this really complements server virtualization. Basically, it's really taking the application layer and making it completely independent of the server on which it really runs. I mean, one example is really the JVM on the Java application layer. I mean, you really run JVM that gives you an environment to run your J2EE applications, right? So that's really a layer of virtualization layer that really runs. And so that's why they say Java is write anywhere, write once, run anywhere. I mean, so you can really develop your applications on a Windows box, on your desktop, and you can run it on, in theory, you can run it on all. Yeah.
I have a question. So when we talk about all these things, what are the key factors that we have to look into that, like, if, for example, if I want to virtualize my application layer, if I want to virtualize like my hardware or like storage places, what are the key factors that we have to look at the data that to make a decision? Okay, hey, I want to make this service virtualized. Like for example, application layer. What are the key data that we need to look into that? Okay, this system needs virtualized.
Okay, the drivers for virtualization is really, if you're looking at servers, right? If you're looking at server virtualization, the drivers are really, utilization is really what drives virtualization. That's one of the things, right? I mean, green IT, yes, on the data center side, people who really manage the data centers, they may really consolidate systems, okay? They may not even really virtualize. I mean, they can just consolidate. I mean, so you really, buy faster machines. Nowadays, every evolution really, increases the efficiency of these machines, right? So that is one way. But if you are somebody who is responsible for buying and managing the infrastructure, you're going to really look at your own utilization of the systems. So when you really have average utilizations that are low, you have to really know, okay, I'm going to port these applications that really run on platform A and consolidate them on platform B. So you have to really have a plan to really port those applications. And on platform B, you really make a decision whether you're going to really run it under the same logical partition, or are you going to really create multiple logical partitions to really have, separate them and really have security,
So basically that I have to have a problem. Basically, if I see there's a problem, either like pricing factor, like budgeting factor, or like memory utilization, like I'm having independent servers and all of them are not utilized, then I should go for.
See, the cost is the driver.
Okay.
Cost, at the end of the day, I said before I handed out here, we talk about CapEx and OpEx in real world. Capital budget. Every customer, every company has a capital budget. They can buy X amount of capital. If that X amount of capital, he gave a very beautiful example of CFO versus CIO. CFO looks at, I spent $20,000, what are you doing? And CIO comes and says, I'm using 20% of the machine that you gave for $20,000. So that means he says, hey, you are using $4,000? What about my $16,000? Where is return? See, that's the driver, return on investment. Then he says, I want another machine because I'm porting another application. He says, why not you use the same box? 4,000. Now you get into a situation of security, two departments using the same box, and how do I split? All this is resolved by LPAS and VMwares or whatever type of virtualization.
I have one more, like this might be not exactly relevant to this, but like I've been a quality control manager, and like for example, if they come and test a product, and like I'll give it a very simple example. In our car, we always have a speedometer like 150 miles per hour, okay? But nobody really goes to 150 miles. Like once you reach 80 miles or 100 miles, your car will be shaking, even though they say it's like 150 miles. So something like that, like in our computers, like we have 3 gigs of CPU, or like there are like going too much. But we are not really utilizing it. Like it crosses 25%. Like most of the time, server crashes. So is it something that those things are getting factorized here?
No, let me make it very clear. If your server crashes, even if I'm running at 100% CPU utilization, there's something else in the problem. Let me be clear. What can happen in operating system world? There is a saturation, 100%. When I was a Unix internal manager in HP before, we used to say 80% equal 100%. When it touches 80%, we show it as 100%. Still there's the elbow. Okay. When it reaches 100%, it could be your machine is completely used. Completely used does not mean it's going to crash. Next stage is your wait queues will start. Okay, your run starts slowing.
Yes.
Then third level is your machine starts
basically.
crashing.
Yeah,
that means it cannot no more it can happen. Is 5 people sitting into the car, 50 people go out at once. None of us can come out. That's the scenario. So if you are crashing, the machine crashes because of load, there's something wrong. If the machine swaps too much, yeah, it could crash because it swapped, it has to bring back the original data. Now, where is it going to overwrite? It will increase the swap. If not, one particular part of time, operating system gives up and says, I cannot retrieve your old data, so I'm going to bring down the machine. So that what you are seeing is not a case for virtualization. It's a case for increasing the capacity. So you ran out of capacity. Here he is talking about available capacity being optimized. Completely opposite.
Yeah, okay, I think I need to go through this. I mean, server virtualization, how do we really do this? I mean, this is a question that was asked. Okay, I mean, there are multiple ways of doing it. I mean, within that, I mean, you can really look at hardware partitioning as one way of doing it, where you really take your hardware resource, and at the hardware level, I mean, let's say you have a platform that's got 10 processors and 20 gig of real memory available. You can really take 10 processors into 5 physical partitions, each with 2 processors, and allocate enough memory in it, to it, and enough disk drives and I/O and all that. So that is really the rightmost way of doing it, hardware partitioning. Then the second level, in the middle is really the bare metal hypervisor. That's also called type 1 hypervisor. I mean, that is really where you have a layer that really runs directly on the hardware itself. And that has the ability to create virtual machines on top of it and manage the virtual machine infrastructure. Okay. The third type is, that's really the IBM mainframes, IBM power systems are all the second type. And VMware ESX is really bare metal. Zen is bare metal. Hosted hypervisor, which is type 2, is really where you have an operating system layer, and on top of that you really run your hypervisor, and the hypervisor gives you the ability to have virtual machines on top.
The previous slide. In the type 1, when I don't have a OS, Zen itself acts like a OS right here.
I'm sorry?
See, in the type 1, type of Zen, there is no operating system basically.
Underneath the hypervisor, there is no operating
That's
system.
it's on bare metal. When we are doing that, Zen itself is an operating system. It does the job of the OS